Hi geometry students, Miss Chapman here. Happy Friday. Hope you guys are doing well. So today, because I'm unable to run a paradox since I'm not there, you guys are going to have a note sheet that you're working on. Throughout the presentation, I will ask you guys to pause my video, work on some problems, and then you can unpause when you're done. So this is actually one of those times. This is your warm-up for today. Please go ahead on your piece of paper and solve these two warm-up problems. When you're done, you can unpause the video. All right, hopefully you remember to go ahead and reduce your radicals. So that square root of 8 would be 4 times 2, okay, or 2 root 2. The square root of 98, the largest perfect square that went into that, was 49. Now, we're going to explore these very special types of triangles today, but I'm hoping that you notice a pattern between the initial legs that were given to you. So each of these were 2. And then your solution, which was 2 root 2. Same thing here. You can go ahead and notice that the legs that were given to you were 7, and your solution for the hypotenuse was 7 root 2. So go ahead and jot down on your note sheet a little note that you might notice between the original legs and your answer for the hypotenuse. All right, the moment of truth I know you guys have been waiting for. Because this is not a paradox, these links are obviously not live. Therefore, in order to view your quiz results from yesterday, you'll need to go to examlogin.com, and your code can be found by your class period. As always, please double, triple, quadruple check me for any mistakes. If there is anything that is not correct, feel free to send me an email. I also ask that you guys go into PowerSchool and make sure that all of your homework grades are accurate thus far, because we want to make sure we have the best start for the semester. Again, feel free to pause me until you're done looking through your quiz. All right, our goal for today is going to be exploring two very special right triangles. The one in the orange box is what we noticed when we had our warm-up this morning. This is the one where we have two legs that will be the same length. And again, we know the two legs are the same length because remember last week when we talked about the largest side being across from the largest angle and the smallest side being across from the smallest angle? Well, if both of these are both 45 degrees, both these angles are the same, so the sides across from them also have to be the same. And again, we'll explore this a little bit more in a bit. Then the other triangle that we're going to look at is something called a 30, 60, 90 triangle, and we'll explore that for the second half of today's lesson. Let's go ahead and dive into these 45, 45, 90 triangles. So again, you'll notice that both of these angles are congruent to each other, and therefore the sides across from them are also going to go ahead and be the same. Okay, those will be congruent also. One of the things that you might have noticed from your warm-up, if you look above, is that both of these legs would be the same amount, and the hypotenuse would be the amount of the leg times root 2. So in your warm-up, you had 2, 2, and 2 root 2. You had 7, 7, and 7 root 2. So we're going to use this formula to help us determine the lengths of 45, 45, 90 triangles, which will save us a ton of time from having to do the Pythagorean theorem every single time. So let's go ahead and step through a few examples, and then I'll have you guys try a few on your own also. So again, one last time, notice these two orange legs are the same, and this blue is going to represent our hypotenuse. So the formula that we're using is in this upper right-hand corner here. Here is my triangle, and some of you guys might be like, oh, Miss Chapman, where are my 45 degree angles? Because you said that this formula only works for 45, 45, 90 triangles. Well, anytime that my legs are congruent, these angles have to be congruent, and therefore 180 minus 90 divided by 2 is also going to go ahead and be 45 degrees. So we can use this formula that's up here. This is really a two-step process for using this formula, and you guys are going to get really, really quick at this, which is why it's so wonderful compared to the Pythagorean theorem. All right, here's your very first step every single time. You have to identify what you are given or where I placed the number. So notice on both my legs here, I have an 8. So you were told that your legs were 8. The next thing that you're going to use is the formula at the top right corner and insert or plug in what you know. So because the leg had a length of 8, instead of writing leg, I'm going to replace it with an 8. Guess what? My hypotenuse is just equal to 8 times the square root of 2, or 8 root 2, and I'm done. Saves so much time from using the Pythagorean theorem. Let me go ahead and go through one more example with you. So for this particular example, we were given that this is a 45, 45, 90 triangle because, again, these two orange legs are the same length. We don't know what they are, but they are the same length because they hold the same variable. So our first step is always going to be identify what we are given, aka where's the number located. So my 28 is located on the hypotenuse. So I was given the hypotenuse. My second step is I'm going to go ahead and use my formula at the top here to calculate the value of my leg. So because I was given that the hypotenuse was 28, I'm going to replace this blue hypotenuse with a 28. Last but not least, I just need to solve for the leg. So to undo the multiplication of the square root of 2, I'm going to divide by the square root of 2. Now we know from last week, right after we came back from winter break, that we're not allowed to have a radical in the denominator. So I'm going to go ahead and rationalize this. Remember, if I want to get the square root out of my denominator, I'm going to multiply by root 2. Please be careful. Whatever you do in the numerator, please also do in the denominator. I'm going to multiply straight across the numerator and straight across the denominator. Mission accomplished, because the square root of 2 times the square root of 2 is the square root of 4, which is just plain old 2. Don't forget to reduce your radical down, and there's the answer for both of your legs. So again, this tends to be a lot quicker than doing the Pythagorean theorem of y squared plus y squared equals 28 squared. Using your formula, and again, you guys are going to get very, very quick at these. All right, it is your turn to try these. Okay, make sure you're using the formula at the top. Go ahead and pause me, work through both of these on your piece of paper, and when you're done, then you can go ahead and restart the video. All right, here are the solutions that you should have gotten when you worked on those two problems. Notice if my leg in problem number 3 is 7, my other leg also has to be 7 because this is a 45, 45, 90 triangle. When I plugged 7 into my formula, I got my hypotenuse to be 7 times the square root of 2, which is 7 root 2. Again, for problem number 4, if my orange leg is 6 root 2, my other orange leg must also be 6 root 2. Both of those orange parts must be the same length. So both legs were 6 root 2. We had to be really careful about our algebra down here at the bottom. To get to my hypotenuse, which was y, I had to take my leg and multiply it by the square root of 2. Well, 6 square root of 2 times square root of 2 is 6 square root of 4. Square root of 4 is a perfect square, so we get 2, and we got 12 for that. Good work, you guys. All right, again, at this point in time, you have these examples on your paper. Go ahead and work through them, and then you can unpause yourself when you're done. All right, we know our legs have to be the same value. So whatever I get for x, I'm going to get the exact same answer for y. That's why my answer is listed this way down here at the bottom. This time, though, I gave you the value of the hypotenuse. So in my formula in the top right corner, I replaced my 12 root 2 with the blue hypotenuse. My goal was to solve for the leg, so to undo the multiplication of the square root of 2, I had to divide it to the other side. Now, again, the most wonderful thing actually happened here. The root 2 in the numerator and the root 2 in the denominator went ahead and canceled. Okay, all right, continuing onward, I gave you here the square, our 15 is the hypotenuse, so replace the blue hypotenuse with 15. To undo the multiplication of root 2, we divide it by root 2. Just like before, we were going to have to go ahead and rationalize that denominator. So I'm multiplying both the numerator and the denominator by the square root of 2 and multiplying straight across the top. My numerator, 15 root 2, denominator square root of 4, which is 2. 15 and 2 cannot reduce, and therefore I am done. All right, last set of 45, 45, 90 triangles to go ahead and try. I'm going to go ahead and pause, or you should pause the video again. When you're done, please unpause, and then you can check your solutions. All right. 16 in my first one was the hypotenuse. I replaced my blue hypotenuse with 16 to undo the multiplication of square root of 2. I divided. You have to rationalize and simplify. For problem number 8, this time you were given a leg. So in your formula, you were replacing leg with 8 root 2. Again, be careful with your algebra here. The square root of 2 times the square root of 2 is the square root of 4, which is a perfect square of 2. And 8 times 2 is 16. That wraps up our 45, 45, 90 triangles. Please keep in mind your legs will always be the same value, the same length, they're congruent, and your hypotenuse we can multiply by square root of 2. All right, this brings us to the second half of our lesson today. And the second very special type of right triangle is called a 30, 60, 90 triangle. For this, we do need to remember that across from the smallest angle is our shortest side. Okay, so that's going to be that red one. Across from our middle, medium-sized angle will be our long leg. And then we know that across from the right angle is always our longest side of our triangle. However, it does possess a special name. We call it the hypotenuse. So we'll call this our short leg. This is our longer leg. I know it's not the longest side, but we're going to call it our long leg. And then this is our hypotenuse. All of these are determined by the angle measures inside of our triangle. To solve 30, 60, 90 triangles, we can no longer use the Pythagorean theorem because we're going to be missing too many values. So we have two formulas to go ahead and solve 30, 60, 90 triangles. The hypotenuse of your triangle is always twice the amount of the short leg. And the long leg is always whatever the short leg is times the square root of 3. So those are your formulas. Let's actually take a look at some values and some numbers to put this into practice. So just like we did before, we're going to want to identify which each of the sides are and what we are given. So I know that across from my right angle is always going to go ahead and be my hypotenuse. Before I even jump into my formulas, I personally like to go ahead and label all of the other sides with what they are also. So across from the 30 is going to be my short leg. Up here in my formulas, I color-coded those red. That's why here also. Across from my 60 is going to be my long leg. Now, the tougher part about this particular triangle set is that we have two formulas to choose from, and you have to choose the first one correctly. Because I was given the hypotenuse, or the blue side, I have to start with my top formula because it has the blue hypotenuse. So I know my formula is that hypotenuse equals short leg times 2. I was told my hypotenuse was 30. My short leg is x. You're welcome to put an x here instead. And then to undo the multiplication of 2, I would just divide 2 to the other side. Now that I know what my short leg is, I can now use my other formula. For every single one of these problems, you are going to have to use both formulas. It just depends which one you use first or second. So for my second formula here, I have my long leg equals whatever answer I got for my short leg times the square root of 3. So my long leg is y. 15 times the square root of 3 is 15 root 3. So again, decide which value you have been given, and you'll use that formula first. All right, you can go ahead and finish up your note sheet. I'm going to post a second video with those solutions. If you need help, don't hesitate to